Hey guys, we have a question here that a few of you have sent to me and just had a question about. So I thought that maybe we could go over this together. It should be down here. You should see a homework question. This is from lesson 1.6. So let's just jump on it. It says the population P in thousands of a small city is given by the following function, where T is time in years. And it wants us to answer parts A through C, and P of T, the function, is given below. Now there is a graph there, and we may use that graph to help us maybe estimate our answer. We can use that, but honestly, I don't need the graph. I have everything I need right there with this function. So let's jump on this. Let's look at these pieces. So when I use this board, what I would typically do is maybe turn the light on where you can see me, but then turn the light off and turn the neon light on so that you can see my markers. So I may disappear, but hopefully the work will shine through. So give me just a second. And fingers crossed that this works for you. I haven't used this board in a while. So the function that we're given is f of x, or better yet, p of t. Let's get this right. P of t is equal to 600t divided by 3t squared plus 4. So the first thing we want to do, part A is asking us to find the growth rate. Another way we can describe that or word that is that we are looking for our rate of change, right? So in other words, part A is asking me to find the derivative. So I need to find my derivative. So, and my derivative is found, if you have me in class, the way I say this, is the bottom, the denominator, times the derivative of the top, which is that 600, minus the top, which is our numerator, times the derivative of the bottom, all over that bottom squared. And I wrote this, the bottom times the derivative of the top. I added that t in there. I don't need that t, right? So this is the calculus. This is the part that you guys need to make sure that we have a solid understanding of. So if you are looking in your notes, the way the theorem, the difference quotient, the way this is broken down is that this is the denominator times the derivative of the numerator minus the numerator times the derivative of my denominator all over my denominator squared. Okay, so I would pause this if you need to write that down. So that's that. That is essentially what I have there, but we want to simplify it, right? So if I simplify this, I may need to write a little bit smaller, and I probably will have to erase some things. But if I multiply 600 times 3t squared, that gives me 800t squared, and then plus 2400, and then that's going to give me minus 3600 t squared, all divided by that denominator. Now I'm not going to touch that denominator. I'm going to leave it just the way it is. I like to have it in factored form. Now the goal is to factor that numerator if we can. We want to simplify it, and a lot of times again factor it if we can. So that's my goal here. But before I do that, before I factor, we want to simplify it by maybe combining like terms. So I'm going to look to see if I have any common terms there. And I have this 1800t squared. and that negative 3600 t squared. So if I combine that, I have a negative 1800 t squared plus 2400 divided by my denominator. I'm not touching that. I'm leaving that just the way that is. And I think if we look at our answer, they didn't make us factor this. Sometimes we can, but they took that as our answer. So I'm going to check that off. That is it. That's my answer for part A. That is part A. Now part B is asking me to find the population after 10 years. Now that's not asking for the rate of change. It's not asking for the growth rate. That is asking for the actual population after 10 years. So to find the population after 10 years, we would refer back to the original function, that P of t. Okay? So I hope this isn't too small, but I would recommend you guys use Desmos if you don't have a graphing calculator to simplify these expressions or to find these answers. So this is asking for the population after 10 years. So what I would do is input 10 into P of t. So part B, and I know I'm running out of room, part B, we want to find P, can you see this? Yes, P of 10, not P prime, but P of 10. So let's go to my computer here and let's put that in. It's kind of dark in here, so give me a minute. So I have a fraction. Let's go ahead and put that in so I don't make any mistakes. So in my numerator, I have 600t, so that's going to be 600 times 10. And in my denominator, I have 3 times 10 squared, and make sure we drop back down, get out of that exponent, plus 4, enter. Okay? Now this is what I have. That's not the answer. Let's look over here for a second. I don't know if I can make that smaller. I know this is a lot going on in one screen. But if I come over here and I zoom out, it's not going to happen for me. I have too many windows open. And there we go. So if I look over here, the answer that I have is not 19.3736. The answer I have is 19,736, and there's a reason. If you go back to the word problem, it says the population is in thousands. So what I found is that after 10 years, the population is 19.736 thousand. So if you want the actual number, we can take that number. I think I can type in answer. Answer, okay, times 1,000, and this is the population, the estimated population after 10 years, and they want it to be rounded to the nearest integer, the nearest whole number. So then we would round this up to 19,737. Okay. Now part C, let's put that down. So that would be 19,737. Part B, or part C, what we want to find is P prime of 10. So we're going to go back to the derivative that we found, which is right here. And then we're going to substitute 10 into this thing, because that gives us our rate of change, right? So what we're going to find is our rate of change, or our growth rate, when time is 10, after 10 years. So then for this part C, we're going to go to that derivative here, and in Desmos, we're going to substitute 10 into that. So I have negative 1,800 times 10 squared plus, oops, let's go back. Told you guys, I knew I would make a mistake. It's very dark in here. Plus 2,400 divided by that denominator, which is that 3 times 10 squared plus 4, all raised to the second power. And I'm going to hit enter. And again, what we found was a negative 1.9217, right? And that is not our answer, and that's because our units is in thousands. So then I could say, well, Desmos, I want to take that answer. I start typing in answer, and it automatically populates that answer for me. But I want to take that answer, and I want to multiply that times 1,000 because I need to give them the answer in the correct units. And if I do that, then I have that negative 1,921, but again they asked me to round to the nearest integer, the nearest whole number, so that would round that up to a negative 1,922. Okay, so I hope this helps. If you guys have any questions, please don't hesitate to reach out. And don't forget, I could write it up here. Remember, this is from section 1.6 homework. All right, see you guys later.